Hello Internet, my name is Quinn and this is Blondihacks. I'm working on my locomotive this week and we're going to make a very distinctive feature on the front and back, and that is the box lights. There's a great big headlamp and a great big rear-facing lamp on this switcher, and we're going to make both of them right now. You'll recall the smoke box has this platform on the top of it, and this may look like a place for a swarfy hood ornament, but in fact there's a headlamp there, and on the back there's another one because there's a rear-facing lamp that goes there that is identical. The history of locomotive lighting systems is super interesting, and if that was an insane statement to you, then this may not be the YouTube channel for you. But I think it's really interesting. We've all seen these old-timey lamps, of course, with this boxy shape on top of a locomotive. Have you ever wondered, though, why they have that shape? It's not just some sort of Art Deco styling choice, it's actually functional. These early lamps were kerosene, and so that box is essentially a little wood stove. It's burning fuel, kerosene, only for light instead of heat. So the boxy shape gave it lots of internal volume for fuel storage and the other infrastructure required, and also gave the locomotive a nice flat spot to put road numbers and other details. So the boxy shape kind of caught on, but there were some round and other shaped ones as well. Now you probably also understand why the little thing on top is there. It's not decorative, it's a little chimney, just like a wood stove. Those combustion gases from the kerosene need somewhere to go. The big downside to kerosene is that it's a pretty terrible light source. It's just not very bright and it's not very focused. So railroads were actually very early adopters to electric lighting. Really around the 1850s through the 1880s, electrification began, especially on passenger locomotives, because electric lighting in passenger coaches became expected. And so you need an electrical source, you need a dynamo on the locomotive. And once you've got onboard electrical for the passenger coaches, you might as well convert all the lighting to electric as well. So pretty rapidly, all of these old kerosene lamps were upgraded to electric carbon arc lamps. And you'll see this in different forms. If you see a round-shaped one, especially like on an A3 switcher, that's definitely a retrofit. They've replaced the entire headlamp with an electric one. But you will also see electric lights inside the old box lights. And in those cases, sometimes it was easier to replace the internals without touching the box. So it still looks like an old kerosene lamp, but it's electric inside. Quick sidebar, there was an additional lighting technology around this same time, the carbide lamp, and this was a really clever technology. These lamps burn acetylene, which burns extremely brightly. It's one of the brightest burning flames you can get. However, of course, acetylene is very, very dangerous to keep around. So these lamps use calcium carbide, which is perfectly stable, but when mixed with water, creates acetylene gas, which is then burned. So it creates its own acetylene on the fly, and thus you never have to store it. It's great technology if you need a really bright light and you don't have electrical. Unfortunately, it came along a little bit too late for railroads. They were already rapidly converting everything to electric, but carbide lamps served a lot of niches, especially early automobiles, bicycles, miners' helmets most famously used carbide lamps, and so on. There were a few of them on locomotives, but they were not popular. Now, of course, our A3 switcher is 1919, which is well after electrification started, but a lot of these locomotives were still built with kerosene box lamps, especially on switchers where they aren't typically running at night, and the lamps are as much for signaling or occasional use in tunnels as they are for general illumination. So the A3 switcher that we are building does have a box lamp. Of course, I won't be running it on kerosene. It will still be functional, but it will be electrical internally. It's going to run on batteries. I'm not going to attempt to build a 1/16 scale steam dynamo, although that is something that some model engineers do. So I've got this big chunk of brass here that is going to be the body of this, and I've got just enough, if I play my cards right, to get 3 of these lamps. Now, I only need 2, but I'll have enough material for an extra in case I scrap one. So I very carefully cut that apart to leave myself room for a boo-boo or 2. And let's get going by shaping this up to final dimension around the outside of this thing. Of course, this is partly for fun, but I also genuinely do like using the shaper for these kinds of cuts, these basic planing and squaring up cuts. The shaper is much quicker to set up than the milling machine, and it doesn't care very much about material or dimension. It doesn't take a lot of passes, and it's really easy to get a nice surface finish, and I'm not putting a lot of wear on expensive milling cutters. Once I've got the outside brought to dimension, I then cut the two pieces apart. Now I've got two blanks that are correctly dimensioned, and now I'm going to square up the ends of each of the two blanks. I'm going to take the unusual step of doing this on the shaper as well. Typically what I do these days is I square up the outside on the shaper because it's fun and easy, and then for squaring up the ends, I'll put that in the milling machine and side mill the ends because it's quicker to get a nice square cut doing that than trying to set up a tall, thin part on the shaper, which is difficult. However, these are squat, large parts, and so it would actually be difficult to side mill these because of the height of them and the size of them. I wouldn't be able to easily get a nice clean side milling cut in a single pass. So in this case, the shaper turns out to be the easier way to square up the ends as well. I will go to the mill for this next series of cuts. I'm going to create the rough shape of the chimney at the top, and this is going to be a series of cuts all the way around the end of the part. I'll throw a milling cutter in here and I'll start by cutting the top of it to the outermost dimension of the chimney, which is kind of the flange just underneath the rain cap. I don't know if you can tell in the picture what I'm talking about there, but that's going to be this cut here. I'm focusing a lot on kind of repeatable setups using end stops here because I do have two of these things to make, one for the front, one for the back. So you'll see me doing lots of repetitive cuts and setups. For example, to get the long side of that chimney flange established, it's a series of cuts down the wide side of each of these parts, but there's 4 identical cuts because I do the same thing from both sides on both parts. An end stop positioned there at the back is making quick work of this, and you'll see that with a combination of cleverness and luck, I managed to get that end stop in a place where it works in both orientations. So once I've done these long side cuts for both parts, then I can actually turn it sideways and do the short side cuts using the same end stop, which means that I didn't have to do any additional edge finding or measurement for these next series of cuts, which are slightly different. As you'll see in a minute, that's going to create some interesting geometrical challenges, but the short side cuts went really quick. This setup, honestly, was super efficient. I was very pleased with my accidental success here. I mean, I guess I thought about it a little bit, but it worked out even better than I could have hoped. Because once those flange cuts are done, now I can come in with a small end mill in this exact same setup and cut the body of the chimney, thin down the area under that flange to create the appearance of the little chimney stem underneath. Again, a series of identical short side cuts and identical long side cuts. This was really surprisingly efficient. I knocked out all 16 of those cuts in no time at all. Now we're at an interesting point. So we've got the shape of the chimney established and the outer dimensions roughed in, but now it's time to create a whole bunch of bevels. You can see in the design of the part that there are decorative bevels on the short sides, and then the top has decorative bevels all the way around the top. And the reason I've modeled this in CAD was because I had to figure out something that didn't make sense looking at the dimensions in the drawing. You would think that these bevels all the way around the top are all the same. They should all be the same angle, right? But they aren't. If you cut them all to the same angle, this is going to happen. You see how there's a little ledge left over on two sides? And that's because the aspect ratio of the chimney is different than the aspect ratio of the box. There's honestly no conceivable reason to have done that in the design. It just is how it is. So I couldn't get the bevels to work out initially, and that's why I modeled it in CAD to figure out how do you make this work. And it turns out you have to have different angles on those bevels on the short and long sides, which also means that those corner edges are not 45 degrees like you would think. They're meeting at like a 44.2 or something degree angle. So it's all a little bit fudgy. So if I want this to work out on my milling cuts, I'm going to need to do separate setups for the long and short sides, and I'm going to have to get those angles just right. It's also notable that the top bevels depend on an edge that's created by the side bevels. This edge right here doesn't exist yet and needs to line up with the top bevels. So I'm going to do the side bevels first, which will then create the references needed for the top bevels. Now for those side bevels, I thought, I bet I can do this on the shaper. I calculated the angle that I would need to tilt the head over to create the correct bevel. And I did some test cuts on a piece of scrap to see if this was going to work. You might notice that tool that I'm using to cut with looks a little strange. It looks like a plain high-speed steel blank. And that is in fact literally what it is, because what I need is a wide, flat cutting edge with a simple 10-degree angle on the back and zero top rake because this is brass. That is exactly the description of a high-speed steel blank. So I didn't even have to grind the tool. I just literally found a tool that had a blank end on one side and used it, and that worked beautifully. You can see how nicely that cut. I'm glad I tested this though, because I did initially try it with my usual tool holder, which is this thing with a small tool bit in it, and this did not work very well. I only got to about half of the bevel width that I was going to need, and it started to chatter quite badly. This was actually a great example of the importance of rigidity in machining setups, and you need rigidity throughout. You need it in the machine, you need it in the setup, you need it in the part, and you need it in the cutter. This is the cutter that worked, and you can see it's a big beefy tool bit, and it's supported right behind the cutting edge all the way back through this packer block into the clapper box. Fully supported. Those cutting forces are going right into the machine. And this is the one that didn't work. You can see how much flimsier it is. It's a much smaller piece of high-speed steel. There's nothing supporting it from behind. And also the top rake on it is not correct because this tool holder has a built-in 10-degree angle in it, which is usually convenient, but not in this case. This is a very high tool pressure operation. This is a very aggressive form tool, and that's an important lesson in machining. The higher your tool pressure is, the more important all of the details are. That means rigidity and speeds and feeds and tool geometry. So this needed to be running very slowly. This needed to be a very rigid setup, and that top rake needed to be the correct 0 degrees for brass. Any of those variables being wrong, and the cut didn't work. I mean, if you're taking 10 thou cuts in brass with a point cutter, I mean, you can get away with just about anything. It doesn't matter if your speeds and feeds are bad or your tool geometry is poor, it'll still pretty much work. But in a situation like this, where you're really pushing the limits, then you got to do it right. And look how nicely that's cutting. This is just magical. This is where the shaper really comes into its own, cuts like this. It's just quietly and slowly making metal go away. It really makes you feel like you're using a refined tool from a more civilized age. And also, you know, it helps that we're not in a hurry here. There's no Nazis that we're trying to outproduce with this particular shaper. To get the geometry of these bevels correct, as I said, I did the trig to figure out what angle the tool head needed to be at, and then I've marked the end point of the top edge of the bevels on the surface plate. So I'm just cutting to those scribe lines, and these are just decorative, so that's sufficient. Once you start joining these bevels together, I'm also watching the corners to make sure that the corners line up nicely. With corner bevels like this, you want to make sure that the depth of cut is the same at the top and bottom of each edge where they meet, otherwise you'll get a little discontinuity that doesn't look good. So in a couple of places I might have stopped short of the layout line or gone a little bit past it if it was necessary to make the corners look good. I really could not be happier with how that went. The bevels all look beautiful, and it was fun to do that on the shaper. Good times all around, except for, well, I made a little mistake. If you're really paying attention, you can see it right now. This material at the top is actually temporary. That needs to go away in order to cut the top bevels. So I shouldn't have cut the top bevels on the short sides, because those are going to go away when I cut the top bevels. And this is where this part gets really weird, because, as I said, the side bevels are necessary because they create the edge for the top bevels. However, that's only true of the long side top bevels. The short side top bevels have to be done first because they create the reference edge for the side top side bevels. Does that make sense? Yeah, so the way you have to do this is short side decorative bevels, long sides first, then all 4 top bevels, then the side short side bevels. I know that's confusing, but the bottom line is, for me, I'm going to have to obliterate 2 of my bevels that I just did when I create the top bevels and then recut the side bevels after. So no harm done, just kind of an amusing interdependency of references there. To cut the top bevels, I'm going to do them on the milling machine because they're considerably wider than those side bevels, and I think they're going to be too wide for the rigidity of even my improved setup on the shaper. I'm going to need to do these with a spinning cutter, so it's over to the mill. Now, to set this up, however, typically an angle cut on the mill, you want to set it up with some kind of angle blocks because you want the mill head to remain square, so you angle the part instead. And in this case, that's going to involve some messy combination of angle blocks that isn't going to repeat on X. And remember, I have 8 of these cuts to make, and two separate angles to do. So a setup like this is going to be a mess. Another option is my tilting table that I have, but again, I'd have to create an elaborate fixturing setup on top in order to make this repeatable because I have multiple cuts and multiple parts to do. Don't love that idea. Instead, I'm going to do something that I think I've never done before, and that's to tilt the mill head itself to make these cuts. This is something I've always meticulously avoided because it, of course, means you have to retram the mill when you're done. However, I think it's a good call here because I have 8 of these cuts to make and I want an easy repeatable setup on the part. So by tilting the mill head, I can leave the part square in the vise and with an end stop so it's easy to repeat, and I can get the 2 different angles that I need easily. The other option here would be to machine some sort of angle fixture that will hold the parts in a repeatable way, but angled holding fixtures are quite a bit of work to make, and I would need 2 of them because I have to have 2 separate angles for these top bevels. In this case, I decided that retramming the mill at the end was going to be quicker and easier than making those angled holding fixtures. Plus, it was weirdly thrilling to do this, actually. I felt kind of naughty tilting the head and making these cuts. It was a pretty fun way to do this, actually. You saw me using the digital protractor on the mill head, and that gave me sufficient accuracy, like to plus or minus 1/10 of a degree, which was necessary because, again, these bevels won't meet nicely on the corners and at the base of the chimney if I don't get these slightly different angles correct on both sides. In this shot, you can see the big advantage of doing it this way. I've got an end stop set up and the part is sitting square in the vise, and I can rotate the part in the vise and keep it square. So interchanging parts and interchanging cuts on each part is super fast and super accurate. So I think this was a good call. And then, of course, once this is done, I have to go back to the shaper and recut the top bevel on each of the sides. But that was no big deal because I just left the shaper set up for it. I'm kind of spoiled now having multiple machines that can overlap in their operations like this, so I can leave one machine set up and go fix a problem on another machine and then come back without losing my setup. That all went really well, far exceeded my expectations, frankly. I wasn't sure about some of those setups, but extremely pleased with the results. Of course, that was, again, really only worth it because I had so many of these angle cuts to do, and now I, of course, have to pay the price, which is to retram my mill. I suppose this is one of those things, though, like tramming the vise. When I first got into this hobby, I dreaded pulling my vise off, absolutely dreaded it. I would do anything to avoid doing that, but honestly, once you get good at it, you can do it so fast that it stops being a burden. So I can retram my mill vise now in under a minute, so I don't hesitate to pull it off and put it back because it just isn't a big deal. So tramming the head might be the same way. If you do it a lot, then maybe it's just not a big deal. I just really don't do it very often and kind of hate doing it. The next job is to punch a great big hole through the center of this thing for the actual light. So I centered up on the mill, and I'll put a little center in the center of each one because that will make the lathe setup much easier and more accurate. Over to the lathe now, I'm going to do these big boring jobs in the 4-jaw chuck. I'm using some pieces of pop can to protect the part from the jaws. You've seen me doing this a lot more lately and using jaw protectors a lot less. And I've honestly been finding that jaw protectors tend to distort the position of the part too much, and they can make it difficult or occasionally impossible to get a part to dial in correctly. So I've kind of switched to using these little pop can shims, especially on small parts where you need a more accurate dial in. It's much more fiddly than the jaw protectors, but dialing in the parts is so much quicker and easier, and it's easier to tap things square and so on. Anyway, great big hole through the middle of these, so I'll start with a big center drill, and then I'll work my way up through a series of twist drills. Seemingly every single time I do a boring operation on the lathe, the boring head mafia demands to know why I didn't do this on the mill, and, well, tell me you have power down feed without telling me you have power down feed, because if you don't, then the boring head is absolutely the worst way to do just about any job unless you have no other choice. On my lathe, I have power feed on my carriage, and so boring cuts are very, very quick. Plus, this is a counter bore that I'm going to be adding on the outside of this afterwards, so there's going to be an internal shoulder, which, unless you have one of those $1,000 fancy moving boring heads, then you can't even do that cut on the mill. These things definitely put the subtractive in subtractive manufacturing, but it didn't take too long with a great big drill to get most of it out of the way, and then a few boring cuts, and then you can see me finishing off the counter bore here. there's a stepped cylinder that goes inside this that actually holds the light bulb itself. That's what this counterbore is for. I did have some concerns about wall thickness at the end of this cut. If the wall thickness is too small, then the jaws will distort the bore as you're cutting it, and you'll end up with a round bore, but then when you relax the jaws, it'll relax the bore and it'll become egg-shaped. So to guard against that, I didn't gronk down on the jaws too tight, I just snugged them up. They don't have to be that tight on a square part because a square part can't rotate in the jaws. You have a mechanical hold, you're not relying on just friction. This bore also has quite a generous tolerance on it, so I aimed for the bottom of that tolerance. In case it did go egg-shaped by a thou or two, I'm still going to be within the tolerance on both dimensions. However, I measured it at the end and it didn't egg-shape at all, so that went just fine. I also considered doing the bore first because it would be easier to hang onto the part before cutting the chimney. However, I was afraid that the thin wall would be a problem because those bevel cuts needed some pretty aggressive vise clamping, especially on the shaper. So this worked out fine. It wasn't too difficult to hold, and I did them both that way, and I think they came out great. The next set of operations is pretty straightforward, just a bunch of bolt patterns. There's a threaded hole in the top that holds the rain cap for the chimney, and some mounting holes and so on around the thing for various panels and so on. Nothing too exciting here, but you'll see me doing all these operations with both parts in the vise, and I've done my edge finding on each one at the same time, and I've created 2 workspaces in TouchDRO. This is a feature that allows you to maintain multiple coordinate systems really easily, so I can do all of the operations between tool changes on both parts at the same time, and by clamping both parts I get nice balanced vise jaws as well. So far so good. There was some tricky operations in there. I recently kicked some crows out of my shop. I don't know if that's related, but honestly everything there went great. Now on top of that we need the little rain cap, so let's go do that. This is going to start, as you might have guessed, over on the shaper with a piece of scrap, which I will cut to outer dimension for these. I'm using the common technique for making pairs of small parts, which is to make them on the ends of a common piece of stock. Makes everything easier to hang on to. After dimensioning, then I round the corners on that, which this is decorative and doesn't have to be that accurate, so I just filed it to the radius gauge, and that's a decent enough approximation of the radius in the drawings. Now I can square up the ends to make them valid references, and once again do my edge finding on each end using 2 separate workspaces in TouchDRO, which gives me a separate origin for each part, which will make it easy to do all of the different cuts. The first cut I do is a little half circle milling cut in from the ends of each part. The other end of each part needs the same feature, but of course the inner ends are joined to each other through the common piece of stock. So for those, again, using the workspace in the DRO, I can translate to the correct position for the left-hand part, and plunge my end mill down, and then switch to the other workspace and feed across, cutting a slot, ending at the correct position for the cutout on the other part, the right-hand part. This would be better with a 2-flute end mill, this plunging and slot cutting, but I didn't have one the correct size, so I'm making do. This is a 4-flute center cutting end mill, but center cutting 4 flutes are kind of a compromise. They work okay, but 2 flutes plunge a lot better. After this cut, then I have the innermost half-circle features that are joined by a superfluous slot that'll be cut apart later, of course. And the next thing to do is the mounting holes down the center of each part. There's a bolt that bolts this to the top of the chimney. And once again, because I've got my 2 separate workspaces, it's trivial to jump back and forth between the parts, do my center drilling, and so on. And then I use an end stop to flip the part over because these need to be countersunk from the other side. So by doing this, I don't lose my X reference on the part, and my 2 workspaces in TouchDRO remain valid, so I can do both of the countersinking operations. Again, no edge finding, no measuring required. At this point, the parts are basically done, but it's time to cut them apart. I've left myself a fairly generous amount of material between them so that I could bandsaw the 2 apart right down the center line and then mill them down to final width separately on the milling machine. There's one of the little chimney pieces. You can see it looks kind of like a stamped sheet metal part from the outside. For these little sheet metal parts, it's easier to actually mill them out of solid to create the look of the original rather than trying to form them or stamp them the way the original was probably made. I wasn't able to source brass screws with the correct thread and head type on them, so steel ones will have to do, but that's okay. This is all going to get powder coated anyway. Well, those are certainly looking the part. Let's see if they look the part on the actual locomotive. Of course, they're far from finished yet. These are just the chassis of the head and tail lights, but this is all I have time for this week, and that is looking pretty good, I think. Certainly looking very locomotive-y now with those headlights on there. Turns out we're not making a boat after all. Imagine my relief. Well, thank you so much for watching, and thanks to my patrons for making all of this happen, and I will see you next time.